Hello, welcome to this Linux Foundation Networking 5G Super Blueprints webinar. My name is LJ Aluzzi. I am a Senior Technical Community Architect with Linux Foundation Networking. Today we're going to present a 5G Super Blueprints use case using EdgeLake's decentralized Edge data platform. Before we start, a few housekeeping items. This webinar is streaming live on LinkedIn and is being recorded. You can find the full recording afterward on the LF Networking YouTube channel. We encourage you to ask questions. If you have questions, drop it in the LinkedIn comments section anytime throughout the webinar. We've set aside the final 10 to 15 minutes for Q&A, and we'll answer as many questions as we can. All participants are expected to follow the Linux Foundation Code of Conduct. Please keep the discussion respectful and constructive. And for today's agenda, we'll start out with an introduction about this webinar. And you also may be asking yourself, what is the 5G Super Blueprints? We'll cover that. We'll cover the value this use case brings to telcos and service providers. Then we'll dive into the technical details. After that, we'll show two production use cases using EdgeLake. We will then talk about how you can work with us to help develop this use case for the telco industry. And finally, we'll have questions and answers. Now I'd like to hand it over to my colleague, Kendall Perez.
Thanks, LJ. Hi, everyone. My name is Kendall Perez. I am the program manager for LFN, and I'm here to just give you a quick introduction. So what is this webinar about? Today's webinar is about a fresh approach to a common problem using a concept called a super blueprint. A super blueprint lays the foundation for integrating various open source projects and blueprints for addressing a specific problem. The blueprint we will discuss today revolves around the need of end users to efficiently manage their data and how communication service providers can address this need while creating new revenue streams. So what will you learn from this webinar? The webinar will highlight common challenges organizations face when managing IoT and different types of data that is generated inside their distributed footprint. You will also hear why existing cloud-centric solutions fall short. We will explain how a super blueprint created by the Linux Foundation Edge and networking communities provides a perfect solution for this problem. You will also learn how both the end users and communications service providers can benefit from adopting this blueprint. So why is this important? The value of open source software is recognized by many industry verticals. However, the challenge of integrating and deploying open source technology in production remains a prohibiting factor. In today's webinar, you will learn how you can leverage the proposed super blueprint, or better yet, take part in shaping it for your specific needs. Back to you, LJ.
Okay, so what is it? What is the 5G Super Blueprints? The 5G Super Blueprints is an LF networking project. It develops and promotes cross-community project integrations between open source projects relevant to the 5G technology space. The 5G Super Blueprint serves as the backbone of LF Networking as the collaboration hub initiative. It's where open source communities, service providers, software vendors, and end users come together to collaborate on leading-edge open source projects. Next slide, please. This slide represents the ecosystem for LF networking, LF Edge, and LF connectivity. It encapsulates the core and cloud, the service provider edge, and the user edge. The 5G Super Blueprints are a series of integration projects that vary in scope and technology and operates across this ecosystem. Integration projects can be end-to-end solutions across this ecosystem or subcomponents within this ecosystem. Now I'd like to introduce Moshe Shadman, the CEO of AnyLog.
Hi, everyone. Great to be here. My name is Moshe Shadman. I'm the founder and CEO of AnyLog. AnyLog is the company beyond EdgeLake, which is the product that enables what we will show you today. And we're very excited to work with the 5G Blueprint and with telco companies to bring it to customers. So just to put things in the right context, I'll start a little bit about what are the existing inefficiencies and challenges that companies are facing today when they need to manage data. And I'll take it I'll try to show and take it all the way to explain how the telco could provide the value here. So if we're looking at what the challenges that companies face today, we see first huge data volumes that are generated outside the cloud. And we all know as people that deal with data that when you have a lot of data, even simple problems are very complicated and expensive to solve. However, those data that is being generated is generated outside the cloud in different formats. The data is distributed in many places, and there are no data services that users could leverage outside the cloud to manage their data. So they end up with no much choice other than moving their data from the edge to the cloud. And that's the problem or the challenge that we are able to solve. And we think that the telcos are the ones that could bring it to the customers. So the question is, can the telco bridge the edge data to the applications? Can they solve the problem that exists today at the edge outside the cloud? And the answer is yes. With EdgeLake, this is the opportunity that we will discuss today, and we will show you how this could be done. So what would be the benefits to the customers, to the end users, with a solution that could service the edge data to the applications? Well, the first thing is real-time insight. I mean, there is so much data that is being generated today outside the cloud, and companies want to get insights and make decisions based on the data. Taking it to the cloud first makes it not in real time, and in many cases, too late. The second value proposition here is the immediate go-to-market today, and we'll show you a few examples of how we were able to transform the data into a setup where customers could extract insight from it, but we could do it also or deliver it as an immediate solution, something that customers could leverage and would be able to immediately leverage their data to get the insight and the decisioning that they need. There are many other value propositions. We'll talk about some of them during the call, but I'll mention just one thing, which is very important for customers, which is the huge cost savings. Replacing edge projects with a plug-and-play solution and lowering the dependency on the cloud and the data services brings a huge cost benefits to the customers. So what is the telco opportunity around it? Well, what we will show you is an opportunity to replace the hyperscalers in servicing the data to the applications. We will show you how the network could take the edge data and service it to the applications without bringing it to the cloud. This is a huge monetization opportunity for the telco, which they could leverage without changes to their existing infrastructure and without huge investments. And maybe very important, why now? Well, I think there are two very interesting trends that make it really needed at this point of time. One is the adoption of and the usage of IoT devices. We see it everywhere. We'll show you two use cases, but it's all over the place. The second is the adoption of AI. And in particular, Edge AI. Edge AI needs all this insight. It needs the IoT data, and companies needs a way to manage the data where it's being created. We don't want to put a process at the edge that needs to make decisions based on data that is coming from the cloud. We want the process to be able to make the decisions based on the data where it's being created and in real time. So just to summarize how companies work today, I'll quickly go over this diagram where we've got all those devices that generate data. The data is being captured at nodes at the edge. Those are nodes near the devices that generate data. It's called user edge. Sometimes it's referred to as the far edge. And from there, the data goes into the service provider edge. Sometimes it's called near edge. This could be nodes on the cell towers that capture the data. From there, the data is being streamed usually through the internet into the cloud and hosted in databases. Only then the data can be serviced to the applications. So if we look at this model, we could say first, capturing the data at the edge by the user requires a lot of effort from the user. It's always done using proprietary projects. I mean, if you look at the edges, there is no platform there. Each company is on its own. Then when it goes into the service provider edge, the service provider edge it cannot really service the data. They use their edge as a station on the way of the data to the cloud. Very complicated to provide service beyond transportation of the data to the cloud. On top of it, there are so many nodes, user nodes and service provider nodes, really hard to manage them, which forces the participants, whether it's the users or the telco provider, to do the minimum that is needed on those edges and just push the data to the cloud. And obviously at the cloud, it's not real time, and we're all aware of the huge costs that customers are facing when they manage their data this way. But again, managing the data at the edge and providing data services at the edge, there is no available service, so companies have no choice other than leveraging this model. And that's exactly what we're changing and what we'll show you, that there is a different opportunity. So the starting point is exactly the same. You've got all those devices and sensors that generate data. They bring it to nodes at the edge. And I'll show you a more detailed setup, how this is built and integrated into the telcos offering. But what happens here, the difference is that rather than having it just nodes, that edge nodes that transport the data forward towards the cloud, edge node is deployed there. And by deploying EdgeLake on those nodes, we are able to create in a completely automated way a virtual layer that presents the data to the applications as if that data is centralized. So the main point that EdgeLake brings is it's able to capture the data from the sensors and devices and cameras in a completely automated way, host it locally, but using the network functionality, present a unified view of the data where queries and processes that had to go before to the cloud in order to be serviced can now be serviced from the data that is in the edge, remains at the edge, doesn't need to move. But at the same time, those queries and processes that need the data are able to interact with the data in exactly the same way that they would interact with the data if the data were to move to the cloud. So what to summarize before we go to a little bit more of the details, trying to summarize what we're bringing to the table in a way. First, in terms of functionality to the users, we're talking about real-time insights versus move the data to the cloud, lose the real-time availability of the data. We're creating a virtual data lake that replaces the need to centralize the data. This virtual data lake is created in a fully automated way. You don't need to send engineers to the edge. You don't need to figure out how to do it. It's completely automated. It enables AI, whether you want to train the models or do the inference or satisfy agents at the edge. All those processes needs data, and this platform services the data directly to those agents and AI processes that needs the data. And we're talking about a plug-and-play solution, plug-and-play integration into the existing network setup. So with this functionality, huge value proposition for the users. First, we're reducing drastically the dependency on the cloud, which has immediate impact on the cost that the customers have to pay for data services, cloud services. It enables immediate go-to-market. This is a plug-and-play solution. This approach allows customers to own their data. The data remains on their nodes, fully controlled by them. They give permissions to processes and users to interact with the data, so they remain in full control of their data versus the cloud, where we need to give the data to the cloud provider. And this solution is open and unified, replacing vendor lock-ins and legacy systems that still exist at the edge. For the telco, it's a huge monetization opportunity that it could capture without investing in new data centers. It's all virtual. It reduces the data transfers, so less leveraging, lowering the usage of their existing infrastructure, so they can provide more services on the existing infrastructure that they have. There is no need to do any infrastructure changes. We'll show you today. It's working. It's an operational system, and there is no need to complex development effort into integrate it. So this is how telcos work today in the context of IoT. So you got the devices that generate data using the telco networks. It's captured to the cell towers, and from there the data starts a journey to the cloud. And again, in the cloud is hosted in databases, and only then can service the applications where the value is provided by the hyperscalers. What we are proposing is this model by deploying EdgeLake on those edges that capture the data, which could be on the cell towers, it could be in the regional data centers. And again, the exact deployment could be different depending on what the customer wants to achieve, what the telco wants to offer, and we could talk with you about it, about the specifics of the implementation. But by capturing the data there using EdgeLake, and again, the process of the data on each one of those edges is completely automated, we are creating a virtual layer that could service the data to the applications as if the data is centralized in the cloud. But the cloud is not part of this model. The data doesn't have to reach the cloud. It's being serviced by the network. So we're taking the role of the cloud providers that service today the edge data to the applications, and we're shifting the role from the cloud into the network. So the value is captured by the network. It's a huge opportunity for the telco providers. It's using the existing infrastructure. So let's look a little bit about the details, what's under the hoods. So this is a diagram of an edge node that EdgeLake is deployed on. What you see here is those boxes, which represent services that that EdgeLake brings to the edge. So today, the edge is missing the data services that the cloud offers. This is one of the reasons why companies move their data to the cloud. So at the edge, companies need to create a stack that would capture the data and deliver the functionality that they need. EdgeLake bridges the gap. Each node is deployed with services that companies only need to enable. So very similar to the cloud. And that would provide the functionality that each node needs to deliver. And the outcome is that streams of data from sensors and cameras are available to the applications as if they are centralized in the cloud, but there is no need to develop any proprietary code. It's all done using an automated way. So more specifically on the diagram, if I'm looking from left to right, you see all those things, whether it's sensors, PLCs, cameras that generate data. They are captured by a variety of APIs that EdgeLake offers, or you could capture the data using third-party software that is available there. Once it reaches into the EdgeLake node through one of those southbound connectors, the data is managed in an automated way and hosted in a local database on the node. But at the same time, the technology makes the data that is captured on the node available on a global layer, on a virtual layer, such that this data is available not only to the node and the processes on the node, but to any process that needs the data using the virtual layer that we showed before. So if we are going from right to left, there are northbound connectors that could service the data to the application. So you could connect to any node in the network using a variety of connectors, whether it's Kafka, REST, MQTT. You could use SQL to query the data. And when you issue a query to a node, this query could be satisfied not only from the data which is locally hosted on the node, but also from the global setup, from the virtual layer, which means that your request or query would be satisfied from all the data that is part of the data set that satisfies the query, regardless of the node that hosts the data. And we'll show you some use cases to make it more tangible and more concrete. At a high level, we could say this platform is being used to predictive maintenance. It could service the telco in specific use cases, whether it's ORAN, it could manage the base station data, the radio intelligent controllers, and so on. It's a platform that would service the data to AI, whether to provide the data to the training process, to the inference process. It delivers real-time insight and information to agentic AI if customers deploy agents in its setup. And we've got the setup supporting federated learning. There is a lot of information on each one of those topics. So if anyone is interested in that, in how to leverage EdgeLake to enable AI, please reach to us after the talk. And with that, I'll let, we've got two very, very exciting projects that are using EdgeLake. A smart city deployment that was done in the city of Sabetha, and a deployment of ships on France and Switzerland rivers. And we're very happy to host here the integrators that have deployed it, Michael and Etienne. So with that, I'll let Michael take it over and talk about the smart city deployment. Michael, you're muted.
Yeah, okay. Thank you. This is a use case based on the city of Sabetha, Kansas, small community, northeastern Kansas. At Sabetha, a legacy system presented the city with some issues to address. We were using a common legacy HMI and historian integrated with PLCs for monitoring and reviewing historical trends and reports for the city utilities. The city of Sabetha replaced old technology with a modern data solution for the city power plant, water plant, and wastewater plant. Problems the city of Sabetha faced include siloed systems, lacking reliability and accessibility. You had to be basically on premise with the right people at the right time. Limited visibility, preventing early issue detection. They had and continue to have a retiring experienced workforce, as well as fewer resources. We seem to be seeing that more often. And reactive maintenance, as well as the loss of experienced workers, led to various failures, some more major failure events, costly repairs, premature equipment replacements. You find your way through those, but it certainly increases blood pressure in a few people. Solutions they looked for, they needed a modern solution that is affordable, supportable, and can integrate additional value-add functionality from any vendor. They are interested in taking advantage of Industry 4.0 technologies, a variety of them, to further assist with removing risks, obstacles, helping out with workflow with younger resources. However, they need a data foundation first. And part of your data strategy is going to definitely be thinking about your foundation. They also needed to ensure personnel are continuously informed, alerted to issues, make the information accessible in more places to more resources. This enables earlier detection and prompt resolution of operational problems, reducing downtime risk and maintenance costs. We started, per this slide, by going to a cloud native solution that we initially thought of that as the digital transformation solution path we wanted. However, for reasons previously explained, we ran into problems and concerns. To summarize, there were various functional problems, technical support challenges, and while the ingress of data can look very cost effective with the cloud, there are cost risks associated with cloud data services, integrations, picking up a lot of random devices one at a time. There's some unknowns and very risky costs that can add up there, and support. Therefore, we pivoted to an EdgeLake solution. Thank you. And today we have industrial PCs as edge gateways sitting at each plant, water, wastewater, and the power. And each of those have a local EdgeLake node on them, a containerized solution, but it's an EdgeLake node. And we have that on the edge. This is simplified. There is ability for redundancy and high availability, but we bring that from the edge where we have, and I want to note, ownership. You can have on paper ownership of your data in the cloud, but you don't have custody of it. We have custody of it. We're not wondering about our data load, except for our memory. We're not wondering about connectivity, speed. We have as much as we want there at each site. And we bring that together in a data lake, and we view that with Grafana dashboards. You switch over to the dashboard. We're not going to go heavy into it. This is some live data that the city of Sabetha has allowed and willingly allows us to promote the idea of. This is just giving you a quick view of a dashboard or two where we present the data in Grafana dashboards and a look and feel that fits you and what your data is. You can go high level, you can go overview. Yes, please go to the next one. There's plenty of drill down you can do, but this is just giving a look of how you can structure your data for an overview. You can get into detail. It can be traditional dashboard. Here's the water plant. You can have as creative as you want to be, whether it's Grafana or whatever dashboard you want. We're really agnostic to that. It's the question is what do you need to present your data. This happens to be a free download version, containerized as well, so it's very effective, and it gives us what we need to monitor it, and with a defense and depth layered security, read only, in a remote capability as well, so that more resources can get it from more places. And with that I will pass off to Edian for his response.
Yeah, thanks a lot, Michael. Etienne, please.
Hello to everybody. Thank you, Moshe. Hello to everybody. My name is Etienne. I am the CEO and co-founder of a company called Another Peak. We are a solution studio for very innovative solutions plus a managed service provider. So a bit of background, this is we are talking about our customer is a company operating cruise ship on 3 different lakes in the French Alps, both in France and in Switzerland. Basically, recently, the founder decided to move to electric power for many good reasons. That's actually the future, electric mobility. And very rapidly, there were some challenges that did happen. And these challenges were really due to the use of batteries. and batteries that have to last for a certain time, typically, at least 10 years. So basically, the need came very quickly from a technology standpoint, how to address 2 points. The first one is best battery lifetime, and the second is make sure that we could assist the pilots in giving them some knowledge and advice on when to charge the boats, when to charge the batteries, and so on. So that's the problem of this new cruise mobility. So, in the past, we would have looked at traditional IoT with a central platform capturing the data from different sources and so on with a very centralized platform. That's the traditional approach. Now, that would have required, of course, to have connectivity full time and so on, which typically on a lake, can be a big problem because depending on where you are on the lake, you may have some difficulty of connectivity. Which is why, we look at actually a solution for managing, data and consuming data, because there is a mix of central consumption and typically, local consumption. So if I look at this central consumption, there is a need about being able to do some offline analytics, building some KPIs that are interesting for the operations and the management of a company. There is a need also to be able to get some data, especially in the future, for preventive maintenance and so on. But there is also a need for local data processing and capacity to use the data locally, especially while on a cruise. So, having a centralized platform would have been actually a source of problem and would have been actually, first of all, old style, but also, would have brought a lot of, let's say, additional cost, which is why we decided to go to a new approach, which was saying, okay, no, first of all, no centralized data. We need to have data locally, but also not just raw data, but what we call refined data and be able to store it locally. The second was, we need to be able to do a central view when needed from time to time and be able to query the different boats and get information about, consumption and additional parameters that I will mention in a few minutes about, coming from the boat. And the third is, being able to process that data locally in order to be able to make some decisions. Help the pilot, assist the pilot in saying, I may need, some to run a generator to add capacity in the batteries and so on. So basically, we have been looking at how can we make it cheaper in terms of design and faster. How can we start from something small and grow, rapidly? Here, we are talking about 13 boats, so there is a growth in terms of number of boats, but also, in terms of features, as you will see. And we want to be future ready. Why? Because we are just at the very beginning of a journey where we'll add more and more features. So Moshe, if you could move to the next slide, please. So we want to get those ships smarter. And if we look, what's under the hood in order to do that, basically, we decided to put an edge, basically in each boat, what we call the boat edge. That includes a certain number of functions, including, of course, AnyLog technology. And this boat edge, basically, is connected to, first of all, to the BMS today, the battery management systems, and to the pilot control dashboard. It's an application, that basically provides information about the cruise, where we are adding some especially decision-making parameters to help the pilot to know, when should I start to use the generator, or should I be careful with my battery? Am I going too fast? So what is interesting here is that we are storing data locally, in those boat edge. And there is, in the operations site, basically another edge where we have two main applications as of today. The first one is the analytics of what is called the state of charge, state of health of every single battery of every single boat, cruise boat, where, we could analyze. And remember, the goal is to make sure that the state of health, in other words, the capacity for the battery to last, is being kept. And then, we want to build a model in the future to help actually optimize the use of the battery. So this is a configuration that we want to be able to make it evolve, especially in terms of additional sensors, typically pollution sensors, but also add different type of consumption model by different, I would say, persona in the architecture. So this is something where we have been promoting also the use of open data in the future, so that people can connect actually outside of the organization. They could connect to this typically both edge and different type of data. Thank you.
Thanks a lot, Etienne. Great project. And with that, let me just maybe emphasize why we brought this webinar. So we are here to support the telecom, and actually any company that is interested to learn or be trained or do a POC with this 5G blueprint and EdgeLake, we've got a lot of experience on how to not only deal with data at the edge and how to integrate it into the needs of the customers, but also how to position it and deliver the message to the customers and how to explain to them the value proposition, which I think if it's being brought to the customers in the right way, it's almost a no-brainer type of proposition. Yeah, so it's at the end of the day, it's an opportunity for the telcos to deliver more services on their existing network without with a huge value proposition to the users. As a plug-and-play solution, is something that could just be deployed and without changes to their existing infrastructure, without investment in new data centers or complicated development. This is what we also try to show you is this is an operational platform. It's not something that needs to be developed and will be ready in, sometimes in the future. It's available now. And we are here to educate you and help you to integrate it into your platforms. You've got the links to get more information and to contact us. Feel free to do that. And we'll be happy to take now any questions from the audience.
Thank you for that. Yes, so time for questions and answers. Please use the comments section on the presentation to ask your questions, and we have several already. Can I try this code?
Yes, the code is available. If you follow the links, you'll be able to download it, as well as the information how to reach us. We'll be happy to help you with that. So yes, the code is available, and we're here to support you in using and leveraging the code base.
Okay, thank you. We have another question. How can I contact you? But yeah, it's right there up on the screen. You have email addresses for myself as well as Moshe, and feel free to reach out. You can also use the QR code where you can dig a little deeper and also have contact information. Okay, yeah, another one. How do you handle security and encryption?
Right. Yeah. So I would say there are two layers of security here. I mean, the first one, or the first thing to notice, is that the data remains where the customer wants it to be. So it could be inside this firewall. Both use cases that explained today, their usage are using VPN, so the access to the data is very secure. On top of it, there is part of the network protocol, there is encryption, and as well as user authentication. They are based on blockchain. It's cryptographically secure. It's a whole presentation on how to leverage it and the value here. But the bottom line, this approach is more secure than the cloud. Unless keys are stolen, nobody would be able to reach out to the data. And the second thing, which is really important in that context, is to understand that users maintain full control of their data. Even us as the developers of the platform are not able to touch the data and see the data unless we get permissions. So it's a really very, very secure platform.
And also, you're going to have some different scenarios where if you have a lot of distributed IoT, the blockchain is great. There are ways that's going to disturb some IT customers in a more fixed four-wall plant. There are ways that you can allow them to have no remote access whatsoever from an individual. You can have their own pipe to their own location in a virtual machine on compute in the cloud, for instance, and you can have a master node model that will meet their IT requirements. This also has, it's a value-added Kubernetes approach that uses IBM Open Horizon, or there's a couple of options there. But there is you sign and can secure your access to your applications on containers that doesn't get to go through any other source. And that's a couple of additional examples where you have several defense in depth layers, and then of course at the edge is Linux as a base that you can utilize and build on.
Yeah.
Okay, thanks. Next question. What is the resources needed at the edge, and are they dependent on the application?
Yeah, that's a great question. So no, so EdgeLake is architected such that it could work from a small switch all the way to the largest server. So we've got deployments on routers and switches at the same time on large servers at the edge or in data centers. So it's very flexible. The footprint and the resource requirements are very slim, and it's not dependent on the applications. I mean, we've got different applications and agents that use the data. There are no requirements, and it could fit whatever the customers want to leverage in terms of hardware resources.
Okay. What is the next question is, what is the maximum data that can be kept at the edge with EdgeLake?
Yeah, so there are multiple, I would say there are multiple layers here. At the core of it, this system is designed to scale horizontally. So as you have more and more data, you could just add more and more nodes. On top of it, there are technologies that are embedded as services in EdgeLake that are focused on dealing with massive data volumes. So we've got aggregation functions. So for example, if you're reading at a high frequency the oil level from a tank, right? So we've got the deployment in oil rigs, and some sensors show data that frequently change. But if you're reading 25 hertz and you're looking at the sensors that looks at the oil level at some tank, that's not going to change. So instead of having thousands of reads in a minute, you could just, using the services that EdgeLake offer, you could summarize it and say, in the last minute, I read 100 times, and the value was X. So, maybe to summarize, the core of it is that you could scale horizontally to deal with the massive amounts of data and just add another node and another node. And on top of it, you've got technologies, which I mentioned just one of them, but there are several technologies that would allow you to capture the data that would be optimized in terms of data volume and management. One more thing which is important to mention: when you deploy EdgeLake, you've got a rule engine, and the rule engine could also deal with the logic that you want to apply to the data, how long you want to keep the data at each node, whether you want to back it up or remove it or move it to a different node. So all those retention policies are represented as policies in a shared metadata layer, where you could, from a single point, manage your entire network and the data there as if everything is running on a single node in a very simple way, and in a very efficient way.
It does depend on the application as well. You can go as lightweight. You can industrialize a Raspberry Pi and have redundant ones, and it might be fine. You could have a server stack. You do scale to what that need is. Obviously, 15, 20,000 plus IO DCS system is going to warrant more. A remote site and telemetry is going to warrant less. and you scale accordingly. And that scale is also what's used to process your on the edge AI with federated learning. So it does depend.
We do have a clarifying question, and it is, are you talking about the EdgeLake overhead or the data itself? Data would clearly be dependent on the application. Is there a limit to the number of nodes scalability?
Yeah. So there is no limit to the number of nodes, and then that's one of the strengths and the uniqueness of the platform. You could add as many nodes that you need. I would say this: when at the end of the day, when you go to some deployment, whether it's boats or a smart city or oil rigs, you look at some pace of ingestion of data, and you have to make some decisions: how long you want to keep the data, your retention policies. If you want to remove the data, where do you remove it to? So all of that is managed using services, and it's really up to you, the integrator or the implementer, to decide how long you want to keep the data, how many nodes. So those are decisions that humans make, but it's very easy to take it and scale it and decide at some point, well, I captured and kept live maybe the last 6 months of data. Now I want to keep 2 years of data, so add more nodes and change the policies. And so it's a very flexible system. There are no, I would say, limits other than the limits that you decide to implement when you decide how many nodes you want to deploy to satisfy a specific setup or a specific application. But it's very flexible, and I would say we haven't seen a use case or a customer that wasn't able to take EdgeLake and adapt it into what he wants to accomplish.
I was talking in my case when I mentioned the IO count. I was talking about the data itself at the edge, however many nodes you want to be redundant. The overhead part, lightweight.
Okay. What language are the rules written in?
So EdgeLake has a rule engine, and it's the rules are in a native EdgeLake language. It's really simple. It's documented. It's you could think about it as the entire, I would say, the entire setup is controlled by native commands, which are provided to the rule engine or to the CLI by the users when they configure and deploy the nodes. It's a very simple scripting language, which takes no time. There is dynamic help, very easy to leverage those codes.
How big, excuse me, how big is the agent that is run at the edge, and how complex is it to plug it into the local data source?
Yeah, the agent is part of the EdgeLake deployment, which is very small in terms of memory footprint and resources. Like I said before, we have deployment of EdgeLake and the rule engine on switches and gateways, so it doesn't require too much resources. It's all the deployment is, all you need is to deploy it and enable the services. There is no complexity. People deploy EdgeLake in large setups, places that require many nodes. They could deploy it in hours and days. There is no decision to make other than these are the services that I want to enable on each one of my edge nodes.
Okay, thank you. That's the last question. One last chance for questions. If you have one, type it in the comments. Otherwise, thank you to all the presenters, and thank you everyone for attending. We encourage you to explore this opportunity to engage with us, and please reach out with any additional questions. Thank you so much.